All right, this example is a very common related rates problem. It shows up on exams and homework assignments all the time, and it has to do with a sliding ladder. So let me explain and we'll walk you through this, because once you know how to do this sliding ladder problem, you pretty much know how to do all of them. They're really all the same. So this says a 13-meter ladder on a horizontal surface is leaning against a vertical wall. So I've drawn a little diagram of that down here where my diagonal line is the ladder. You can see that's my ladder. And then here's this horizontal surface, and then here's the vertical wall over here. And they say the foot of the ladder is pulled away from the wall at 1 meter per second. So here's the foot of the ladder, or the bottom of the ladder, and that's being pulled away from this vertical wall at 1 meter per second. And then they ask, how fast is the top of the ladder, right here, sliding toward the ground when the distance between the foot of the ladder and the wall is 5 meters. So the first step to any sliding ladder problem, at least the first step I like to take, is I like to summarize all of the information that I've been given and the information that I need to find in a little box down here. And I start off by determining each length, side length measurement of this right triangle that you see is formed here. All of these sliding ladder problems form a right triangle. And I've denoted that with this 90-degree angle symbol right here. So again, here's the ladder, here's the horizontal surface, and the vertical surface. So if I want to solve for each side length, I need to figure out what I have and what do I need. Well, they already told me the length of the ladder was 13 meters, so that's going to be our hypotenuse here, or this side of the right triangle. And that's 13 meters. So I have C, and generally when you have a right triangle you can label the sides A, B, and C, with C being the longest side. And then A, I actually didn't have that. I had to solve for that, and we'll walk through that in a second. But B, this length, they gave me in the problem, right? They said when the foot of the ladder is 5 meters from the vertical wall, right? They said this was 5 meters. So I had this, and whenever you have two sides of a right triangle, you can always solve from the third side with the Pythagorean theorem. So the Pythagorean theorem, a squared plus b squared equals c squared, here we'll solve for a. So if we want to isolate a, we'll subtract b squared to this side, and that'll leave us with a squared equals c squared minus b squared. Then you take the square root of both sides, and you're left with a equals the square root of c squared minus b squared, and I simply plugged in c and b here from the problem, and you get a, this side length must be 12 meters. So now I have all my side lengths. Now I want the rate at which these lengths are changing. So DADT means the change of the side length A with respect to time, or the change of A over the change in time. dBdt simply means the change of B, this side, with respect to time, or the change of B over the change in time. And similarly for C, that's the same definition. So DADT, if you notice, this is actually what they were asking for in the problem. They asked, how fast is the top of the ladder sliding towards the ground? So here's the top of the ladder, here's the ground. This is A, right? They want to know how fast it's changing. They want to know how fast this is sliding down, so we want DADT, so that's why I left that as a question mark. dBdt, we were given in the problem. They said the foot of the ladder is sliding away from this vertical wall at 1 meter per second, right? We know the rate at which B is changing. That was 1 meter per second. And C, that was our ladder, right? So that's actually not going to change in length because it's a ladder. So it's hopefully going to stay locked and the same length. But dc dt, we know mathematically that means it's going to be 0 meters per second, because this side never changes length. It's just sort of sliding down, and it's not going to change its length, it's just sliding. So now the Pythagorean theorem is actually also going to serve as the basis for our related rates equation. So now that we've summarized all the information we have and the information we're looking for, we write our related rates expression or equation over here. So in order to do that, we implicitly derive a squared, b squared, and c squared. In other words, we simply take the derivative of each term as we go. And in order to do that, we have to use the chain rule. But you really end up with the same thing every time here. So you can just remember that if you use the power rule, a squared, you bring down the 2, you're left with 2a, and then the chain rule says you multiply that by the derivative of a. So you're left with 2a DADT, 2b dB dt, it's the same thing, just a different letter, a different variable, and then finally 2c dC dt. Now it's simply an algebra problem. We plug in our knowns and our unknowns and we solve for what we want, dA dt. Well, we know a here, we solve for that, that was 12, so that's going to go here, and we want dA dt, so I'll leave that as a variable. Then 2 times b, we were given that, that's 5 meters, so I'll plug that in there. dB dt, we were given that, I'll plug in a 1 for there. And then 2 times c, which was 13 meters, I'll plug that in there. And then dC dt was 0, so really this whole term is going to go to 0, so we really don't even have to worry about it. So after that, we'll start to simplify. So 2 times 12 is 24 times dA dt, plus 2 times 5 times 1, which is 10, equals 0. So the next step you'll take is you'll subtract 10 from both sides here, and you'll be left with 24 dA dt equals negative 10. Then what you'll want to do to isolate dA dt is divide both sides by 24, and you'll be left with dA dt equals negative 10 over 24, or negative 5 over 12. So that means the top of the ladder is sliding towards the ground at 5/12 meters per second. Notice how we got a negative answer. That's because this value is decreasing. But they asked how fast is the top of the ladder sliding towards the ground? Well, it's coming down at 5/12 meters per second. So less than 1 meter per second, but we were able to successfully solve for dA dt. So I hope that makes sense.